Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. All right, lesson 17, Trigonometric Identity Proofs. Classwork opening exercise. We have seen that sine of alpha plus beta does not equal the sine of alpha plus the sine of beta. So what is the sine of alpha plus beta? Begin by completing the following table. All right, so I've created this diagram for you, and we'll refer to that as we go. It says in the teacher edition, students may use calculators, but it's a really good idea for you to get really comfortable and familiar with the unit circle and the values of it. So that's why I have it here, so that the calculator is not a necessity. All right, so I'm going to start off by looking at alpha and beta. So here's alpha, it's pi over 6. So we're talking about this angle right here, this green one here. So if you drew a right triangle, it'd be right there, okay? I don't want to clutter this up. So to get to pi over 6, you have to go over a half and up the square root of 3 over 2. So the sine of alpha, the sine of pi over 6 is 1/2. And beta is pi over 6. So the sine of beta is pi over 6. Sine of pi over 6 is 1/2. Sine of pi over 6, again, is a half. So these just repeated here. So therefore, these two answers are the same. So I'm just going through all these and pointing these out to you. Here's another sine of pi over 6. And the sine of that pi over 6 is 1/2. Here's another pi over 6, and the sine of it is 1/2. Okay. And then they gave us the sine of pi over 3. Well, the sine of pi over 3 is right here. Pi over 3, you go over 1/2 and up the square root of 3 over 2. So the sine is opposite, which is the square root of 3 over 2. So the sine of pi over 3 is the square root of 3 over 2. Here's a pi over 3. Here's a pi over 3. Here's a pi over 3. So the sine of those are all root 3 over 2. And then they went to the sine of pi over 4. Pi over 4 is right here. And the cosine of pi over 4 is the square root of 2 over 2. And the sine of pi over 4 is the square root of 2 over 2 because it's a 45, 45, 90 triangle. So the opposites are equal. Or the legs are equal, I'm sorry. Opposite is equal to hypotenuse. No, it's not. Opposite is equal to adjacent. Ay caramba. All right, the sine of pi over 4 is the square root of 2 over 2. Pi over 4, root 2 over 2. Pi over 4, sine of pi over 4, root 2 over 2. Oh, here's another pi over 4, root 2 over 2. I'm going to leave those color codes there for now. Okay, and then we're going to continue on. So here they did this column for us. The sine of A plus B. Well, the sine of alpha plus beta. So we take the sine of this plus this. Well, pi over 6 plus pi over 6 equals 2 pi over 6, which is pi over 3. Well, pi over 3 is the green. So the sine of pi over 3 is root 3 over 2, and therefore there it is. Okay? Sine of alpha plus beta. All right, so hopefully that makes sense to you. So now we're going to do pi over 6 plus pi over 3. So pi over 6 plus pi over 3 is 2 pi over 6. Well, that equals 3 pi over 6, which equals pi over 2. Okay? Pi over 2. The sine of pi over 2 is right here. Here's pi over 2. It's 6 pi over 12 or pi over 2. It's right here. And that's over 0 up 1. So that's where the 1 came from. Okay, continuing on. Pi over 4, pi over 6, common denominator would be 12. Pi over 4 is 3 pi over 12. You have to multiply 4 by 3 to get 12. And this would be 2 pi over 12. 3 pi over 12 plus 2 pi over 12 is 5 pi over 12. So this is why I did this diagram. Now if I break these into pi over 12, this is pi over 12. 2 pi over 12 is pi over 6. 3 pi over 12 is pi over 4. 4 pi over 12 is pi over 3. 5 pi over 12 is in between pi over 3 and 6 pi over 12, which is pi over 2. So it's halfway between 4 pi over 12 and 6 pi over 12. 4 pi, so pi over 12, 2 pi over 3, 4, 5, 6 pi over 12. Got it? So then I exploded this. I pointed out to you that it creates a right triangle right here where this side is a certain length and this is a certain length. And this is a length of 1 because it's our radius of our circle. So we want to take pi over 12 and we want sine of that pi over 12. So if I get my calculator now and I take the sine of pi divided by 12, I get it's not pi over 12, it's 5 pi over 12. Sine of 5 pi divided by 12 is, that's better, 0.9659. Okay? So that means this side over here is almost 1. 0.96 is very close to 1. And obviously it's very close to the hypotenuse in length. The bigger this angle gets, the closer the opposite gets to the hypotenuse. Sine of 5 pi over 12 is 0.9659. Well, they have root 2 plus root 6 over 4. So let's just check that. So if I take the sine of the square root of 2 plus the square root of 6 divided by 12, or 4, I mean. Okay, I'm going to need another parentheses because I want to put the numerator in, I want to put the numerator in parentheses, so it keeps it together, and dividing that by 4. If I just left the 4 outside the parentheses, it would have been the sine of this, and then divide the whole thing by 4, and that's a different value. So when I do that, root 2 plus root 6 divided by, I don't want to take the sine of that. So again, let me start this again. I want to take the sine of 5 pi divided by 12. And that should equal root 2 plus root 6 over 4. So if I just take and put the square root of 2 plus the square root of 6, struggling here, square root 6 divided by 4, I should get that 0.9659, which I do. So the sine of 5 pi over 12 was 0.96, and they have it in radical form, which is root 2 plus root 6 over 4. So the decimals are equal. So just pointing that out to you, this is the same value as the sine of 5 pi over 12. Okay, continuing on. Pi over 4 plus pi over 4 is pi over 2. So this would be pi over 2 if I added these, and that's what we're doing here, sine of alpha plus beta. Pi over 2, again, is 1. The sine of pi over 2 is 1. Okay, and then sine of alpha plus beta, well, pi over 3 plus pi over 3, pi over 3 plus pi over 3 equals 2 pi over 3. And I put that right here. So that's right here. 2 pi over 3 is going to be the same value for sine of pi over 3 and the negative of the cosine of that same angle, because we're going left and then up. So it'd be this triangle reflected over, so that cosine would be negative and sine is still positive. So it's root 3 over 2. So it's going to be the same as, so the sine of 2 pi over 3 equals the sine of pi over 3, which is root 3 over 2. Okay. And then again, now we have pi over 3 plus pi over 4. And have we done that yet? No. So the common denominator would be 12. So that's the first thing I'm going to do is change the common denominator to 12. I have to multiply this by 4, so that'd be 4 pi over 12. Okay, and multiply this by 3 would give me 3 pi over 12. And adding those gives me 7 pi over 12. Okay, well, where is that on the unit circle? 1, 2, 3, 4, 5, 6, 7 pi over 12 is right here, halfway between 7 pi over 12, or halfway between pi over 2, which is 6 pi over 12, and 2 pi over 3, which is 8 pi over 12. So 7 pi over 12 is right here, and the sine of that will equal the sine of 5 pi over 12, which is right here. So this is equal to that. Okay? All right, so there's that column. So we're doing one column at a time. Now let me get these values out of the way. Actually, no, I could leave those. Just get rid of this mess. Like so. Okay, so now what we're going to do is we're going to, let me change to red here. We're going to take the sine of alpha, which is this column right here, and multiply it by the cosine, careful, cosine of beta. So we don't have a column of cosine values. So I'm going to need to make one. So I will do that over here, and I'll put it right here. Just give me a moment. Okay, so here's what I'm going to do. I'm going to put a column here. I'm going to take the cosine of beta. Beta is pi over 6. What's the cosine of pi over 6? Well, the sine's a half, and cosine would be the square root of 3 over 2. Okay, cosine of pi over 3. Pi over 3 is up here. That is 1/2 comma root 3 over 2, so it's 1/2. The cosine of pi over 6, again, there's a repeat. That's root 3 over 2. Cosine of pi over 4. Pi over 4 is root 2 over 2, comma root 2 over 2. Cosine's root 2 over 2. Here's a duplicate, pi over 3, so take the cosine of pi over 3, it's a half again. And the cosine of pi over 4 repeats, that's root 2 over 2. Okay, hopefully you saw where I got those. Pi over 4, root 2 over 2, root 2 over 2. So now I'm going to take the sine of alpha, which is this column, and the cosine of beta, which is this column. So root 3 over 2 times, root 3 times 1 is root 3. 2 times 2 is 4. And that's where root 3 over 4 came from. 1/2 times 1/2 is 1/4. Okay, root 3 over 2 is the same as 2 square root 3 over 4. So 2 root 3 over 4 plus root 2 plus root 6, they say is root 6. So let's check that. Oh wait, I'm sorry. Root 2, yeah, 2 square root 3 over 4 times root 2 over 2. Actually, no, I don't need to do that. I was looking at the wrong column. So what I'm doing is sine of alpha, which is root 2 over 2, times cosine of beta, which is root 3 over 2. Root 3 times root 2 is the square root of 6. 2 times 2 is 4. Okay, got it. All right, just got to be careful here. Sine of alpha is the square root of 2 over 2. Cosine of beta is the square root of 2 over 2. Square root of 2 times the square root of 2 is 2. 2 times 2 is 4. That will reduce to 1/2. Okay, now we're taking 1/2 times the square root of 3 over 2. 1/2 times the square root of 3. Or 1 times the square root of 3 is the square root of 3. 2 times 2 is 4. And then the square root of 2 times the square root of 3 is the square root of 6 over 2 times 2, which is 4. All right, so there's column sine alpha times cosine beta. All right, now we're going to do, I'll leave this here for now. We may need it again. Now we're going to do the sine of alpha. Let me change the color. Let's use purple now. The sine of alpha, this column, times the sine of beta. I have not done the sine of beta. Yes, I have. It's right here. They have. So now it's this times this. 1/2 times 1/2. Whoops. I highlighted this at the beginning. There is an error in the book. It did it for you. It did it incorrectly for you. Please cross out 1/2 and change that to a quarter. 1/2 times 1/2 is not 1/2, it's a quarter. The sine of alpha times the sine of beta. 1 times the square root of 3 is the square root of 3, and 2 times 2 is 4. So it's root 3 over 4. Sine of alpha, root 2 over 2 times 1/2. Root 2 times 1 is the square root of 2. 2 times 2 is 4. And then this times this, root 2 times the root 2 is 2. 2 times 2 is 4. 2 over 4 is 1/2. That's correct. Square root of 3 times the square root of 3 is 3. 2 times 2 is 4. Square root of 3 times 2, square root of 2 is the square root of 6. 2 times 2 is 4. All right. Now we don't have a column for the cosine of alpha. So I will put that here. Let me just squeeze it in here. Cosine of alpha is going to go right here. So the cosine of alpha, so the cosine of this first column right here, the cosine of pi over 6, I'll put in my calculator. Cosine pi divided by 6 is 0.8660. What is 0.8660? Okay, just a moment. Okay, root 3 over 2 is 0.8660. So that is the square root of 3 over 2. So the cosine of beta and the cosine of alpha is going to be the same, right? Because the cosine of, we already did it, cosine of beta was pi over 6, alpha pi over 6. So I didn't really even need to do that in the calculator. All right, so now the cosine of alpha, there's pi over 6 again. It's the square root of 3 over 2. Cosine of pi over 4 is right here. That's root 2 over 2 comma root 2 over 2. So that's going to be root 2 over 2. And here's pi over 4 again. So that's the square root of 2 over 2. And the cosine of pi over 3 is up here. Cosine is 1/2. Okay, we already did it right here. Cosine of beta, cosine of pi over 3, 1/2, 1/2. And here it is again, 1/2. So there's our column that we're going to use for cosine of alpha. So let me just erase all these lines. So arrows, cosine of alpha. Cosine of alpha is here. Cosine of beta. Cosine of beta. We're multiplying these two columns that we just created. Okay? All right, so here we go. What color? Use green this time. Root 3 times root 3. 3. 2 times 2, 4. Root 3 times 1. Root 3. 2 times 2, 4. Root 2 times root 3. Root 6. 2 times 2, 4. Root 2 times root 2, 2. 2 times 2, 4. 2 over 4 is 1/2. 1 times 1, 1. 2 times 2, 4. 1 times square root of 2, square root of 2. 2 times 2, 4. Column's done. All right, now let me erase these arrows. And now we're going to do the cosine of alpha. Now let's change the color. I don't want green next to green. What color have I not used yet? Blue. Cosine of alpha is right here. Sine of beta is right here. So we're multiplying this first column in purple with this column here. Square root of 3 times 1, square root of 3. 2 times 2, 4. Square root of 3 times the square root of 3 is 3. 2 times 2, 4. Square root of 2 times 1, square root 2, 2 times 2, 4. Square root of 2 times the square root of 2 is 2. 2 times 2 is 4. That equals a half. 1 times root 3 is the root 3. 2 times 2 is 4. 1 times the square root of 2 is the square root of 2. 2 times 2 is 4. Okay, so you completed the table. Okay, so now we're on to page 2, but before I address this, let's go back to page 1. And let me ask this one question. How do we get this column from these columns? How do I get the square root of 3 over 2 from what we calculated over here? So if I'm going to get a square root of 3 in the numerator, I need a square root of 3 in the numerator of my numbers that I'm going to combine here. So I'm trying to find what sine of alpha plus beta equals. So I would say the sine of alpha plus beta equals. And I'm trying to figure out how to get root 3 over 2 from these values over here. I have a square root of 3 here. I have a 1, I have a 3, I have a square root of 3. If I add any of these that are not radicals, root 3 plus 1 is 1 plus root 3. I can't combine them. 3 plus the square root of 3 is 3 plus the square root of 3. They're non-like terms. I can't combine them. But the square root of 3 plus the square root of 3 is 2 square root 3 over the same denominator 4, and then that 2 reduces. So what I'm saying is if I add sine of alpha cosine beta to cosine alpha sine beta, that would add this to this. Well, the square root of 3 plus the square root of 3 is 2 square root 3 and over 4. Since the denominator is the same, we just keep the same denominator. Well, 2 reduces, 2 over 4 reduces to 1 over 2, and we get root 3 over 2. All right. So then when I check that, 1/4 plus 3/4 equals 1. The square root of 6 plus the square root of 2 all over 4, square root of 2 plus square root of 6. And then finally, we get 1/2 plus 1/2 equals 1. Square root of 3 plus the square root of 3 is 2 root 3 over 4, which reduces to square root of 3 over 2. And here we have root 2 plus the square root of 6 over 4. So what they're doing is they're taking the cosine of alpha times the sine of beta. Okay, they're taking that column and they're adding it to this column. Oops. Don't want a parentheses there. So it's sine of alpha cosine beta. Okay, so the sine of alpha plus beta equals the cosine of alpha sine of beta plus the sine of alpha cosine beta. Very interesting. Okay, so that's how we get this shaded column here from multiplying those two. Now let's move on to the next table, and there I found 3 errors in the given table. So now we're given this table, and it says sine of alpha sine beta I brought in from the last page. Right here, all I did was copy this column, so I didn't have to rewrite it. And then I did some checking. And I saw that they have cosine of alpha, which is cosine of pi over 6. Okay. And the cosine, which is not 1/2, by the way. The cosine of pi over 6 is root 3 over 2. The sine of pi over 6 is 1/2. So cross these out in your book. These are both root 3 over 2. And when you check that, they're taking the sine of alpha times the cosine of beta, the sine of alpha times the cosine of beta. 1 times root 3 is root 3, 2 times 2 is 4. They get the right product here, but they just typed in a half here by mistake. It's root 3 over 2, okay? But then when I got over to sine alpha, sine beta, I went through all of these just to make sure. Sine of alpha is a half. Sine of beta is a half. 1/2 times 1/2 is not 1/2, it is 1/4. So there were 3 errors in that first row. Other than that, the rest of the table is correct. And then let's come up with a conjecture for cosine of alpha plus beta. So I'll write that down here. The cosine of alpha plus beta equals, in other words, how did we get this shaded column? Okay, so root 3 over 4 plus root 3 over 4. So I can't add these two this time like I did in the last one. That'd be 2 root 3 over 4, root 3 over 2, and I don't have root 3 over 2 here. I have a half. Okay, and let's check that. That is correct because cosine of alpha plus beta, pi over 6 plus pi over 6 is pi over 3, and the cosine of pi over 3 is a half, so that's correct. These were all correct. I checked them. So how do I get a half from these? Well, I'm going to focus on this here. 3/4 minus 1/4 is a half. Root 3 over 4 minus root 3 over 4 is 0. Root 6 minus root 2 over 4. So there it is. It is this column minus this column going this way. So it's going to be cosine alpha times cosine beta minus sine alpha sine beta. And that is how we get this column here. We can't do it the other way around because root 6 minus root 2 is not the same as the square root of 2 minus the square root of 6. You're not going to get the same value. Okay, it's either going to be positive or negative. All right, so it's going to be order matters. So continuing checking, 1/2 minus 1/2 is 0. 1/4 minus 3/4 is a negative 1/2. So if I don't write these correctly, if I did it in the wrong order, I would have gotten positive 1/2 if I subtracted the other way. So be careful. And this is root 2 minus root 6. Okay. So there is what cosine alpha plus beta equals. It's cosine alpha cosine beta. So remember it that way. It's the same order, cosine alpha cosine beta minus cosine beta cosine alpha. All right, now let's go back to the last one. Sine alpha plus beta. Addition doesn't really matter. It's commutative, but we still should do it in the right order. So alpha and beta are in that order. So you say cosine of the first, sine of the second, plus sine of the first, cosine of the second. All right. So I'm going to copy these and put them together. All right. So now let's look at these together. Cosine alpha plus beta equals cosine alpha cosine beta minus sine alpha sine beta. So notice everything's in the same order except the sign here. So when we have the cosine of the sums, we subtract. When we have the sine of the sums, we add. Sine, add, cosine, subtract. Everything's all in the same order. All right, page 3 brings us to example 1 and 2, formulas for sine alpha plus beta and cosine alpha plus beta. Okay, so it says one conjecture is that the formula for the sine of the sum of two numbers is the sine of alpha. Why is that so dark? The sine of alpha plus beta equals the sine of alpha times the cosine of beta plus cosine alpha times sine beta. Okay, we just got that from that table in the last page. The proof can be a little long, but it is fairly straightforward. We will prove only the case when the two numbers are positive and their sum is less than pi over 2. So we're only working in the first quarter of the circle, first quadrant of the unit circle, 0 to pi over 2. So let alpha and beta be positive real numbers such that the sum of alpha and beta is going to be between 0 and pi over 2. Okay, so now it says to construct rectangle MNOP. So here it is, MNOP. Here's the rectangle here, such that PR is 1. So picture our unit circle is what they're doing. And let me bring that in just real quick. Okay, so here's this unit circle, this purple circle here. Here would be our X and Y axes. This is the origin. This would be a radius of 1. So PR is 1. So therefore, P all the way out past M to this point here is 1. And P out past O to here is also 1. So we are in the first quadrant between 0 and pi over 2. So we're in that area. And that's what this proof is talking about. Okay, so I just wanted to point that out to you. So it says let them be between 0 and pi over 2. There the sums are. And so part B says construct the rectangle such that PR is 1. The measure of angle PQR is 90 degrees. They have it labeled. And the measure of angle RPQ is beta. And the measure of angle QPM is alpha. See the figure on the right? So there it is. Fill in the blanks in terms of alpha and beta. The measure of angle RPO. So the measure of angle RPO is right here. Well, if this is a rectangle, okay, and we were told it was, construct rectangle MNOP. What do we know about rectangles? Opposite sides are congruent and parallel, and there's 4 right angles. So this is a total of 90 degrees. So the measure of angle RPO would be 90 degrees, but we're talking radians. So instead of saying 90 degrees, we would say pi over 2 minus beta plus alpha. Okay, but that is going to be, if I distribute this minus sign without having parentheses, it would be pi over 2 minus beta minus alpha. Okay, so it's the whole thing minus beta and alpha would give us angle OPR or RPO. RPO, OPR, same thing. Okay, so it's pi over 2 minus beta minus alpha. Okay, and let me just keep it in the right order. So notice we have alpha first, beta, alpha first, beta, alpha first, beta, and then I wrote beta first, alpha. So let me just change that. So this would be alpha plus beta, and this would be minus alpha minus beta, just to keep them in order, alpha, beta, alpha, beta. The measure of angle PRO, that would be this angle here, would therefore be 90 or pi over 2. Well, actually, here's what we would do here. This is parallel to this. ON is parallel to PM, and PR is a transversal. So we have alternate interior angles. So this is equal to that. So therefore, the measure of angle PRO is equal to the measure of angle RPM because they're alternate interior angles. So this would also be alpha plus beta. Okay. All right. Number 3. Therefore, sine of alpha plus beta, in other words, sine of angle ORP equals PO. Okay. Remember that sine is opposite over hypotenuse, and the hypotenuse here is 1. So anything divided by 1 is itself. So the sine of alpha plus beta equals the side PO. Okay, so this side right here is the sine of alpha plus beta, side OP. Part 4 says RQ equals the sine of what? Well, sine is opposite over hypotenuse. Opposite in this case is RQ over 1. Okay, so the sine of beta is opposite RQ over 1. So that's RQ. PQ would be the cosine of beta. So cosine of beta is PQ over 1. It's just simply PQ. Okay, got that so far? Now move on to part D. Let's label the angle and the length measurements as shown. So they did that for us. They put A plus B in here. Here's the sine of A plus B over here, like we figured out. And pi over 2 minus alpha minus beta is this angle here. Okay, so they just filled it in for us for this step. I have color coded these so that you can, so the 3 triangles stand out, or actually 4. Okay, and so it says use the new figure to fill in the blanks in terms of alpha and beta. Why does the sine of alpha equal MQ over cosine B? So alpha is right here. Here's alpha. The sine of alpha is opposite over hypotenuse. Okay, sine is opposite over hypotenuse. The opposite is MQ. The hypotenuse is cos B, so MQ over cosine B. Okay, so putting it into words, we would say the length of the hypotenuse of triangle PQM, the red triangle, is cosine of beta. And MQ is the length of the side opposite alpha, and therefore the sine is opposite over hypotenuse, or MQ over cosine B. Number 2, therefore, MQ equals what? What does MQ equal? Well, all they're asking for is us to solve for MQ from here. So how do I get rid of this division of cosine B? Opposite, or the inverse of division is multiplication. So we multiply over to the other side, and that would give us the sine, oops, wrong place. The sine of alpha times cosine of beta equals MQ. And it says equals MQ right here, so I don't need to write that again. So all we do is take cosine of B, multiply it on both sides. It would cancel over here, leaving sine alpha times cosine beta on the left. And I'm putting alpha first, beta second, because that's how it is drawn up in our equation up top. Okay, now it says part 3, the measure of angle RQN. All right, well, here's what we're going to do to explain this. MQ is right here. It is the sine of alpha times the cosine of beta. That's MQ. Okay. OP is the sine of alpha plus beta. So therefore, NM is the sine of alpha plus beta. And this piece is sine of alpha times cosine beta. Let me go up a little bit here where I highlighted. Sine of alpha plus beta, which is OP, equals, so I'm going to write that right here. That's OP. And OP is equal to MN. But sine of alpha cosine beta is MQ plus, and we need QN over here. So there's cosine alpha, sine beta. So this is cosine alpha sine beta, because sine alpha cosine beta plus cosine alpha sine beta equals sine alpha plus beta, and MN equals PO because this is a rectangle. Pretty cool stuff here. Okay, so now that we know that, this side here is cosine alpha over sine of beta. Well, if this angle right here is RQN, this side right here, remember, cosine is adjacent over hypotenuse. So cosine of alpha times sine beta would be this angle, or this side right here. So therefore, let me erase that. This has to be alpha. Okay, so the cosine of alpha times the sine of beta will give us this side. So therefore, this angle has to be alpha. Okay, so here's our new drawn up diagram, filling in everything that we have found. Pi over 2 minus alpha minus beta is this angle. Alpha plus beta is this angle. This is alpha. This is cosine alpha sine beta, and this is sine alpha cosine beta. Okay. Now we'll consider triangle RQN. So it is this triangle right here. I had it in blue, but I covered it up now. QN equals what? Cosine theta, or cosine alpha sine beta. So this is cosine alpha sine beta. All right, and then part G says label these lengths and angle measurements in the figure. So this is what your figure should look like. Okie dokie. Okay, page 4 brings this all together. So I brought over the diagram from page 3, and part H now says, after labeling that all up, since MNOP is a rectangle, OP, which is the left side, equals MQ plus QN, which is the sum of the right side, since the left side equals the length of the right side. So OP equals MQ plus QN, and therefore, thus sine of alpha plus beta equals the sine of alpha cosine beta plus cosine alpha sine beta. Note that we have only proven the formula for the sine of the sum of two real numbers, alpha and beta, in the case where the sum of those two numbers is between 0 and pi over 2. A proof for all real numbers, alpha and beta, breaks down into cases that are proven similarly to the case we have just seen. Although we are omitting the full proof, this formula holds for all real numbers, alpha and beta, regardless of whether we are in this, pi over 2 to pi, or pi to 3 pi over 2, or 3 pi over 2 to 2 pi. So therefore, we can now state this. For any real numbers, alpha and beta, the sine of alpha plus beta equals the sine of alpha times the cosine of beta plus the cosine of alpha plus times the sine of beta. Now let's prove our other conjecture, which is that the formula for the cosine of the sum of two numbers is cosine alpha plus beta equals cosine alpha times cosine beta minus sine alpha sine beta. Again, we will prove only the case where the two numbers are positive and their sum is less than pi over 2. This time we will use the sign addition formula and identities from previous lessons instead of working through a geometric proof. So fill in the blanks in the terms of alpha and beta. Let alpha and beta be any real numbers. Then, okay, so we're given cosine of alpha plus beta equals the sine of pi over 2 minus, well, it's going to be that alpha plus beta. Okay, cosine of one angle is equal to the sine of 90 or pi over 2 in radians minus the other angle. That's where that comes from. So therefore, then we're going to distribute the negative throughout. So negative, think of a -1 here times alpha. So it would be the sine of negative alpha. Oops. Sine of negative alpha minus beta. Okay. I forgot my pi over 2. So it's pi over 2 minus alpha, distributing this, and then minus beta. And then moving the parentheses, which is associative property. So then what do we have? We have the sine of pi over 2 minus alpha, that doesn't change. And we just said plus a negative beta, which is the same, okay? And then that would give us the sine of pi over 2 minus alpha times the cosine of negative beta plus the cosine of pi over 2 minus alpha times the sine of negative beta. Okay. Because what we're doing here is we're using this formula. Think of pi over 2 minus alpha as just the alpha, and the minus beta as just the beta. So it's, actually, it's the whole thing. So this is going to be our beta. See the plus sign right here? Pi over 2 minus alpha is going to be our alpha piece. So this is sine of alpha plus beta. So it equals the sine of alpha, cosine of beta, plus cosine of alpha, sine of our beta. Okay, hopefully you can see that. And then we simplify. So cosine alpha, cosine negative beta, where did that come from? And then we have plus sine alpha, sine negative beta. All right, well, the sine of negative beta is right here. The cosine of negative beta is right here. But if we take the sine of pi over 2 minus alpha, that's the same as the cosine of alpha. Because the sine of 90 minus one angle is equal to the cosine of the other angle. And same with here. Okay, so hopefully you follow that. And then that simplifies to cosine of alpha, cosine beta minus sine alpha, sine beta. So what happened there? Okay, multiply the whole thing by -1, or actually, okay, so keep in mind we are in the first quadrant. So if we are in the first quadrant, we're somewhere over here. So cosine is this direction to the right. And cosine, if I went this way and then down negative beta, cosine alpha, cosine negative beta, the negative beta would be this way, but it's going to be the same distance if we go to the right. Negative sine, or sine alpha, sine negative beta, a sine alpha positive is up, a sine of negative beta is down. So we negate the sine alpha and get a positive sine beta. For all real numbers, alpha and beta, therefore the cosine of alpha plus beta equals the cosine of alpha cosine beta minus sine alpha sine beta. So let me clarify this last step right here. Keep in mind that the cosine of negative beta equals the cosine of beta. And then the sine of a negative beta is going to equal the negative of the sine of beta. That's a beta. Okay. So this cos negative beta just becomes cos beta. So cosine alpha, cosine negative beta would be the same as cosine alpha, cosine beta, because these two are equivalent. The sine of alpha, sine of negative beta is the negative sine of beta. So that will negate this product. Positive times a positive is positive, but then now this becomes a negative sine beta. So they kind of skipped a step here. So if I had in between here, plus sine alpha times a negative sine of beta, a positive times a negative gives you this negative. Okay, so that's where that came from. Okay, page 5 brings us to exercise 1 and 2, formulas for sine of alpha minus beta and cosine alpha minus beta. So number 1 says to rewrite the expression sine alpha minus beta as sine of alpha plus a negative beta. Okay, so minus is the same as plus a negative. And we're going to use this formula here it says use the rewritten formula to find a formula of the sine of the difference of two angles, recalling that the sine is an odd function. So the first thing we want to do is state that alpha, let alpha and beta be any real number. Then we would say the sine, what's my thing doing here? The sine of alpha minus beta, or I'm sorry, plus beta equals, we're using the alpha plus beta thing here. The sine of alpha plus a negative beta, let's fix that. Yeah. So we're using this, the sine of alpha plus a negative beta equals, so that's right here. So it's going to be the sine of alpha times the cosine of what our beta is, and in this case, it's a negative beta, plus cosine of alpha, okay, times the sine of our beta, which is negative beta, okay? So that is going to equal, the sine of alpha is going to stay the same. Cosine of negative beta is the same as the cosine of positive beta. So now let's just change that to a positive beta. Plus, actually it's going to become minus, remember, cosine of alpha doesn't change. And then it's going to be the sine of beta. Remember that the sine of negative beta is the negative sine of beta, and the positive times negative gives us this negative over here. Okay, therefore sine of alpha, okay, so rewrite this expression. So therefore we can now state that this is also equivalent to the sine of alpha minus beta is going to equal the sine of alpha cosine beta minus cosine alpha sine beta. For all real numbers, alpha and beta. Okay, so I brought in the formula for the sum of cosines. And we're going to find the cosine of the difference of two angles. So first thing we want to do is say let alpha and beta be in real numbers, then the cosine of alpha minus beta equals the cosine of alpha plus a negative beta. Okay, that's the first step. So that's going to become, so we have a cosine of alpha equals cosine alpha times the cosine of beta, and in our case it's the negative beta, minus the sine of alpha times the sine of beta, and our beta is a negative beta. So that is going to equal cosine of alpha. Remember, cosine of negative beta is the same as cosine of beta. And then this is going to be plus, because the sine of a negative beta is the same as negative sine of positive beta, and a negative times a negative is positive. So that's going to give us the sine of alpha, the sine of the positive beta. Okay, so therefore, the cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. And the sine of alpha minus beta is the sine alpha cosine beta minus cosine alpha sine beta. All right, page 6 brings us to exercises 3, 4, and 5. We're actually probably just 3 and 4 on this page. Number 3, derive a formula for the tangent of alpha plus beta in terms of tangent alpha and tangent beta, where all of the expressions are defined. Hint, use the addition formulas for sine and cosine. So I brought the hint in. Here's the definitions we came up with on the last page. Sine and cosine formulas for addition. So first thing we want to do is restrict our domain. So we say let alpha and beta be any real number so that the cosine of alpha cannot equal 0. And the cosine of beta cannot equal 0 because remember that tangent is sine over cosine. So cosine cannot equal 0. And we're also going to see that sine cannot equal 0. So it says by the definition of tangent, tangent of alpha plus beta equals sine of alpha plus beta divided by cosine alpha plus beta. So all we're going to do is substitute this in for those two values. So tan alpha plus beta equals this. Therefore, we continue by saying that the sine of alpha plus beta is the sine of alpha cosine beta plus cosine alpha sine beta. Okay, so we just substituted sine alpha plus beta for what this equation says over here. And that's all going to be divided by the cosine of alpha plus beta, which is the cosine of alpha cosine beta plus, minus the sine of alpha times the sine of beta. Okay, so we just substituted in our formulas into here. So obviously now you can see that cosine alpha cannot equal 0. The cosine of beta cannot equal 0. Okay? Because the denominator is cosine alpha plus beta. All right, so now we have this formula. So now let's simplify that. What does that simplify out to be? Okay, so what are we going to do? We're going to divide numerator and denominator by cosine alpha cosine beta. All right. Okay, so this might look a little tricky to you, but we're going to divide the number and the numerator and the denominator by cos A, cos B. So I'm going to rewrite this as sine alpha cosine beta plus cosine alpha sine beta. So I just wrote the numerator up here, but now I'm going to divide that numerator by cosine alpha cosine beta. Okay, and then I'm going to take this cosine alpha cosine beta minus sine alpha sine beta, which we already had in the denominator, and I'm going to divide that by cosine alpha cosine beta. Okay, so if I'm going to take cosine alpha cosine beta and put it in the numerator and the denominator, anything divided by itself is 1, therefore it cancels. Okay, so what's going to happen here? Well, the cosine, you can rewrite this now when you have the same denominator. I could actually take this cosine, oops, what is going on? All right, it didn't write it into different pieces. So let me just erase this and I'm gonna move it. Okay, it's not wrong, but I'm just showing you what happens when you have the whole denominator. It's going to be cosine alpha gets distributed to both parts, and I had cosine beta and cosine alpha cosine beta over here, and it'd be 2 fractions. Okay, that's all I'm doing. And the same would go for down below. So this would be over here. Breaking it up into 2 fractions where you have cosine alpha cosine beta again. Okay, so then what's going to happen is, let me use red to cancel, cosine alpha, cosine beta minus sine alpha, sine beta, cosine alpha, cosine beta. So what's going to happen here is the cosine beta and the cosine beta are going to cancel because anything divided by itself is 1. And over here, the cosine alpha will cancel. Okay. And notice this is all the same. Cosine alpha, cosine alpha, cosine beta, those all sort of cancel. It's careful. You have to be careful how you say cancel. So anyway, and when everything cancels, anything divided by itself, think of that as 1 minus. I'm just going to put that there for now. Okay. And let's go back to canceling. So we have sine of alpha, sine beta, cosine beta. Okay. So that's, I'm just going to leave that for now. So everything is canceled. Well, what is sine alpha divided by cosine alpha? That is tangent of alpha. Plus, what is sine beta over cosine beta? That is tangent of beta. And anything divided by itself is 1 minus, and sine over cosine is tangent. So that's tangent alpha. And sine beta over cosine beta is tangent beta. Okay. And there you have it. So now we can say that tangent alpha plus beta equals the tangent of alpha plus the tangent of beta divided by 1 minus tangent alpha times the tangent of beta. For all alpha and beta where the cosine of alpha does not equal 0, cosine of beta does not equal 0, and their sums do not, the cosine of their sums does not equal 0. Whew. Okay, now number 4 says derive a formula for the sine of 2 times u in terms of sine of u and cosine of u for all real numbers u. All right, so the first thing we want to do is say let u be any real number. Okay, and then once you say that, then we're going to say, therefore, then we say the sine of 2u equals the sine of u plus u, right? Everybody agree that that's true? All right, so then we're going to use this formula right here, sine of alpha plus beta. Alpha is u and beta is u in this case, and therefore that is going to equal the sine of alpha, the sine of u, cosine of u, plus cosine of u, sine of u. Okay, just substituting in. My alpha and my beta are both u in this case, so it's just sine u, cos u, plus cos u, sine u. Okay, and that's it. This can simplify as well. This has a sine, and this has a sine, and this has a cosine, and this has a cosine. So I could factor out the sine and the cosine. Okay, so it's sine u, cos u, or that's going to equal 2 of the sine u's, cos u's. Okay, so it's these two things are the same, Their orders are different, but multiplication is commutative. So I can move this sine u over in front of cos u. So it's sine u cos u plus sine u cos u, which is 2 sine u cos u's. Okay, number 5. Derive a formula for cosine u in terms of sine u and cosine u for all real numbers u. So you want to say let u be any real number again. I'm not going to write that, but that's what you have to write there. And then you say the cosine of 2u equals the cosine of u plus u. Okay, and that is going to equal right here cosine of u, which is our beta, minus sine of u, right? Since alpha and beta are the same. So we're getting, let me fix that. So cosine of 2u equals the cosine of u plus u. So we're using the sum of cosines rule, which says cosine of alpha plus cosine beta. Well, alpha and beta are both u. So cosine u minus sine u. And that's going to simplify to 2 cos u minus 2 sine of u. Oops, I'm sorry, that's not right. Cos times cos is not 2 cos. Ay caramba. It is cos squared u minus sine squared u. Okay, so then what we would have is, let me write this in here, by the way. Cos 2u equals cos squared u minus sine squared u. So cos 2u equals cos squared u minus sine squared u for all real numbers u. But then when we use the Pythagorean identities, we can rewrite the identity as cos 2u equals 2 cos squared u minus 1. Or as cos 2u equals 1 minus 2 sine squared u for all real numbers u. Because cosine squared minus sine squared equals 1 is an identity, or cosine squared plus sine squared equals 1, then we get this. So let me write that down here. Sine squared u plus cosine squared u equals 1. That would be the identity. But we have cos 2u equals sine 1 minus sine 2 sine u, because there's a 2 here. Okay? Anyway. Okay, page 7 brings us to the end of lesson 17. Go to your problem set.